We've talked about portfolio risk before. Here we will discuss the subject in a little more detail. First, a quick recap. The risk of a portfolio depends on the risk of the individual assets, the weights of each asset in the portfolio, and the covariance or correlation between the assets. And here are the formulas for the risk of a portfolio that you should be very familiar with by now. I have shown you both forms, the one that uses correlation and the one that uses covariance. The covariance between 1 and 2 is simply the correlation times standard deviation 1 times the standard deviation of 2. The point that we will emphasize now is that the diversification benefit improves. In other words, the riskiness of the portfolio comes down as the correlation decreases. Notice that if the correlation is 1, then we will have a certain number and there will be no diversification benefit. As this number comes down, clearly the risk will come down. If the correlation is 0, then this whole term vanishes and the risk comes down even more. If the correlation is negative, then we have this plus this and then minus a number. So clearly, as the correlation between assets goes up, the risk of the portfolio will come down. And if you want, you can plug some numbers and convince yourself of that fact. Covariance and correlation. Covariance is a measure of how two variables move together. The values range from minus infinity to positive infinity. The problem with covariance is that it is difficult to interpret. If you know that the covariance is 27, is that a high relationship? Is that a high covariance or a low covariance? We are not sure. We just know that there is a positive covariance. But the degree to which the two variables move together is not clear just by looking at this number. Correlation, however, is a standardized measure of the linear relationship between two variables. The values range between -1 and 1. A correlation of 1 means that there is perfect positive correlation between two variables. They move up and down together. A correlation of 0 means that there is no correlation between two variables. Most stocks, for example, will have a correlation somewhere between 0 and 1. A correlation of -1 means that there is perfect negative correlation between two variables. The formula that connects correlation with covariance is given right here, and these are two forms of the same formula. I would suggest that you simply remember this formula. The covariance between two variables is simply equal to the correlation times the standard deviation of the first variable times the standard deviation of the second variable. Once you know this formula, then it is very easy to derive the other one. Portfolio expected return and variance. Let's say we have a portfolio of two stocks, X and Y, and you are given this data. You are told that X has an expected return of 12%, standard deviation of 16%, Y has an expected return of 20% and a standard deviation of 20%. You are also given the correlation. What we need to do here is come up with the expected return and risk of the portfolio. And then we need to look at how the risk and return changes when the weights of X and Y change. Simplistically, here is what's going on. This is the portfolio with two assets, X and Y. The risk of each asset is given by the standard deviation of that asset. So X by itself has a risk of 16% or 0.16. Y by itself has a higher risk of 30% or 0.3. The question is that when these two assets are combined in a portfolio, then what is the risk of that portfolio and what is the expected return of the portfolio? We have already talked about the expected return of the portfolio as being the weighted average of the two returns. So this is a fairly straightforward calculation. we take the weighted average of the two returns and get an expected return of the portfolio equal to 15.2%. Notice that in coming up with the expected return of the portfolio, we only worry about the weights and the returns. The risk of each asset and the covariance between the two assets does not impact our expected return. The risk of the overall portfolio, however, depends on the weight of each asset in the portfolio, the risk of each asset, and the correlation between the two assets. Notice that in this formula we have used the correlation times the standard deviation of each. Instead of this, we could also use the covariance. You could plug in the formula that you saw earlier that connects covariance with these elements. Let us plug in the numbers over here. W1 is 0.6, so we do 0.6 squared into the standard deviation of x, which is 0.16 squared. When we plug in the rest of the numbers, here is what we should get. We can also do the calculations for other weights. For example, if the weight is 100% X, then we'll have a situation where the expected return of the portfolio is 12% and standard deviation is 16. As we add more and more of Y, the expected return and the standard deviation is going to change. If you run through this exercise at different weights, roughly speaking, here is what you will get. If you are 100% invested in X, let's say that's represented by this portfolio over here, then your expected return is 12% and the standard deviation is 16%. As you start adding Y to the portfolio, initially you will get a diversification benefit because the correlation between the two assets X and Y is less than 1. Diversification benefit means that you can increase your return while decreasing the risk. So notice we are moving to the left, which means risk is going down, and we are moving up, which means that the expected return is coming up. After a certain point, however, both risk and return will go up. And as we keep adding Y, we will get to a point where we are 100% invested in Y, and there the expected return will be 20%, which is the expected return of Y, and the risk will be 30%, which is the risk associated with investment Y. So hopefully it is clear that as we move along this segment, the weightages are changing. Initially we are all X over here. As we move northwest and then northeast, the weight of X is going down and the weight of Y is coming up. Initially there is a diversification benefit, but after this point in time, then both the risk and the return increase together. Now I want you to work on example 4 in the curriculum. In fact, we will do that through this example. Please read through it. You will notice that all the numbers are similar to what you have seen before. The difference is that now we will also look at the impact of using different correlations. Earlier we used a correlation of 0.5. Now we will also use these other correlation numbers. I want you to pause the video and do this example for the various correlations. This will seem tedious, but at least once in your life you should do this. Roughly speaking, here's what you should come up with. If you use a correlation of 1, then there is no diversification benefit. You can be totally invested in X, have a risk of 16 and an expected return of 12%. As you increase the weightage of Y, you simply move northeast. In other words, you have higher risk and higher return. With the correlation of 0.5, there is some diversification benefit, and this is what we saw earlier. Initially, as you decrease the weight of X and increase the weight of Y, the risk will come down, but the return will go up. That's because you are getting your diversification benefit. Eventually, you will turn around and the higher return will come at the cost of higher risk. With a correlation of -1, which is ideal from a diversification point, you can actually find a certain weight of X and Y such that risk can be eliminated. In level 3, we solve for those weightages. If you are good with algebra, you can do that over here also, but strictly speaking, that is not necessary at level 1. The basic point is that as the correlation becomes less, the diversification benefit increases. The maximum diversification benefit is if the correlation is as low as possible, which would be -1. A few miscellaneous points. We have talked about portfolios with two assets because all the relevant concepts can be understood using two asset portfolios. However, in the real world, we have many assets in a portfolio. The expected return of a portfolio with multiple assets will simply be the weighted average of the return of all the assets in the portfolio. But what about the risk of a portfolio with many assets? Let's take a 3-asset scenario. The risk or the variance will be as follows. Let's say we have 3 assets. So we'll have W1 squared, sigma 1 squared, plus W2 squared, sigma 2 squared. And then we will take 3 pairwise correlations. So we will have 2 times W1, W2, the correlation, and then sigma 1, sigma 2. Then the other pairwise correlation, 2 W1, W3, rho sigma 1, sigma 3, 2 times W2, W3, the rho between 2 and 3, and then sigma 2, sigma 3. Clearly, this is the correlation between 1 and 2. This is the correlation between 1 and 3. Now, you can see why something like this probably will not show up on the exam. Conceptually, it is straightforward, but from a calculation perspective, it can get fairly tedious. The power of diversification, we have talked about this already. I'd strongly encourage you to read example 11 in the curriculum, which illustrates this very well. Simplistically, I'll explain what the example is about. It talks about two portfolios, portfolio 1 and 2. Portfolio 1 involves buying a company that sells beachwear and another company that essentially has snack shops at the beach. And portfolio 2 consists of the beachwear company and a DVD rental company. In both portfolios, we have two stocks or two assets, but clearly portfolio 2 is better diversified. Why? On a sunny day, the beachwear company will do well and the snack shop at the beach will do well. So your portfolio will do very well. On a bad day, both these stocks will do badly. So your overall return will be negative on both fronts. But with portfolio 2, you are diversified in the sense that on a sunny day, a good beach day, this will do well and this will do badly. On a rainy day, this company, the DVD rental company, will do well and this will not do so well. The good and the bad over here cancel each other out a whole lot better. So this clearly is a more diversified portfolio. The diversification benefit is higher. Also take a look at exhibit 23 in the curriculum. You don't need to learn this, but it's good general knowledge because you can look at the correlation among different asset classes, at least in the United States. The simple point to illustrate is that in the real world, as you are creating portfolios for your clients and you are picking different asset classes, it is important to understand the correlation between the asset classes when you create portfolios. And finally, this is not really part of the learning objectives, but just at a high level, you need to understand how to diversify. And simplistically speaking, you can diversify by investing in different industries. You can diversify by investing in different geographies, different parts of the world, and so on.